This question sets the stage for a quiz about a machine learning model. We'll be examining the behavior of OneVsRestClassifier, a technique used for multi-class classification problems. The question asks you to identify which statements correctly describe how this specific type of model works. Statement A describes a core aspect of OneVsRestClassifier. It suggests that the model tackles the three-class iris prediction problem by building three separate binary classifiers. Each classifier focuses on distinguishing one iris species, Setosa, versicolor, or virginica, from the other two. This is the essence of the OneVsRest strategy. Statement B explains how the model makes its final prediction. After the three binary classifiers have produced their probability scores, each indicating how likely a given iris flower is to belong to its target class, the model picks the class with the highest score. Think of it as a competition. The classifier with the highest confidence wins. Statement C addresses the problem of class imbalance. Class imbalance means that there are unequal numbers of samples for each class in the training data. It claims that OneVsRestClassifier automatically addresses this issue. This statement is important because class imbalance can significantly impact model performance. Statement D introduces another multi-class classification strategy, 1vs1. Unlike OneVsRestClassifier, a 1vs1 strategy builds a separate binary classifier for every pair of classes. For this three-class problem, this would involve three classifiers. This line introduces a diagram or figure, likely illustrating the architectural setup of the 1vsRestClassifier. This would be a label in the diagram from line 9. It represents one of the binary classifiers. The classifier is designed to distinguish iris flowers of the Setosa species from the other species, versicolor and virginica. It contrasts one class with the rest. Okay, let's dive into the heart of this multi-class classification problem. This row represents the core machine learning model we're using, the 1vsRestClassifier. It's a powerful tool for tackling problems where we have more than two possible outcomes, like predicting iris species. This is where our journey begins. We start with the famous iris dataset. This dataset contains measurements, like sepal length and width, petal length and width. These are our features, which describe different iris flowers. These features are fed into the 1vsRestClassifier as input to make predictions. This line simply reiterates that we are using a OneVsRestClassifier model. It's a way of converting a multi-class problem into multiple binary classification problems. This means instead of directly predicting one of three iris species in one go, the model builds three separate smaller problems to solve the original multi-class problem more efficiently. Here's the magic. The 1vsRestClassifier creates three separate binary classifiers. This first one focuses solely on distinguishing iris Setosa from the other two species, versicolor and virginica. It learns the patterns that separate Setosa from the rest. Next, another binary classifier focuses exclusively on distinguishing iris versicolor from iris Setosa and iris virginica. This helps the model isolate the characteristics that are unique to iris versicolor. Similarly, this third classifier works specifically on identifying iris virginica by comparing it to iris Setosa and iris versicolor. After training each binary classifier, each classifier provides a probability score for each iris flower. These scores indicate the likelihood of the flower belonging to the specific class the classifier was trained to predict, e.g., probability of being Setosa, probability of being versicolor, probability of being virginica. Finally, the 1vsRestClassifier aggregates the probability scores from the three binary classifiers. The iris species with the highest probability score is selected as the predicted species for each flower. This completes the classification process. Hey Vamsi, this refers to the overall structure of the 1vsRestClassifier model. It's a smart way to tackle multi-class problems by breaking them down into a series of simpler binary classification tasks. Think of it like this. Instead of trying to sort all the irises at once, we create separate sorting stations, each focusing on one type of iris against all the others. Hey Vamsi, this refers to the overall structure of the 1vsRestClassifier model. It's a smart way to tackle multi-class problems by breaking them down into a series of simpler binary classification tasks. Think of it like this. Instead of trying to sort all the irises at once, we create separate sorting stations, each focusing on one type of iris against all the others. This is our dataset, VOMC. It contains information about 3 different types of iris flowers: setosa, versicolor, and virginica. Our goal is to build a model that can correctly identify which type of iris a new flower is based on its characteristics. This is our dataset, VOMC. It contains information about 3 different types of iris flowers: setosa, versicolor, and virginica. Our goal is to build a model that can correctly identify which type of iris a new flower is based on its characteristics. Here, we build the first of our 3 binary classifiers. This one focuses solely on distinguishing setosa irises from all other irises: versicolor and virginica. It learns the unique characteristics that make setosa different. Here, we build the first of our 3 binary classifiers. This one focuses solely on distinguishing setosa irises from all other irises: versicolor and virginica. It learns the unique characteristics that make setosa different. Now, we're creating a second classifier. It works in a similar way to the first one but focuses on identifying versicolor irises, separating them from setosa and virginica. Notice the pattern? Now, we're creating a second classifier. It works in a similar way to the first one but focuses on identifying versicolor irises, separating them from setosa and virginica. Notice the pattern? Finally, we train the third and last binary classifier. Its task is to identify virginica irises, differentiating them from setosa and versicolor. Each classifier specializes in recognizing one specific iris species. Finally, we train the third and last binary classifier. Its task is to identify virginica irises, differentiating them from setosa and versicolor. Each classifier specializes in recognizing one specific iris species. After training VOMC, when a new iris flower arrives, each of our 3 classifiers provides a probability score. For instance, Classifier 1 might say there's a 90% chance it's setosa, Classifier 2 a 5% chance it's versicolor, and Classifier 3 a 5% chance it's virginica. These probabilities tell us how confident each classifier is about its prediction. After training VOMC, when a new iris flower arrives, each of our 3 classifiers provides a probability score. For instance, Classifier 1 might say there's a 90% chance it's setosa, Classifier 2 a 5% chance it's versicolor, and Classifier 3 a 5% chance it's virginica. These probabilities tell us how confident each classifier is about its prediction. The final prediction is simple: VOMC. We choose the class, iris type, that receive the highest probability score from the 3 classifiers. In our example, the model would predict setosa, because it received the highest probability, 90%. It's a democratic process. The classifier with the highest confidence wins. The final prediction is simple: VOMC. We choose the class, iris type, that receive the highest probability score from the 3 classifiers. In our example, the model would predict setosa, because it received the highest probability, 90%. It's a democratic process. The classifier with the highest confidence wins. The iris dataset is a classic dataset in machine learning, used to test and showcase various classification algorithms. It contains information about different iris species, setosa, versicolor, and virginica, and their corresponding measurements: sepal length, sepal width, petal length, petal width. This is the data we'll be using to train and test the OneVsRestClassifier model. Let's dive in. One of the 3 binary classifiers needed for the OneVsRest strategy. This specific classifier learns to distinguish between iris setosa and the combined group of iris versicolor and iris virginica. It learns the distinguishing characteristics of iris setosa compared to the other 2 species. This is just one of the 3 classifiers working together. Similar to classifier 1, but this classifier focuses on iris versicolor. This classifier learns to differentiate iris versicolor from Iris setosa, and Iris virginica. Think of it as learning the unique features of Iris versicolor in comparison to the other iris types. The final binary classifier trains to differentiate Iris virginica from Iris setosa and Iris versicolor. It hones in on the characteristics that make Iris virginica unique compared to the other species. What do you think are the key differences between these species? After training, each of the three classifiers will produce a probability score for a new, unseen iris sample. This score represents the confidence that the classifier assigns to the specific flower belonging to the class. For instance, if the flower is likely to be setosa, the corresponding probability score will be high. Once we have probability scores from all three classifiers, the final prediction is made. The classifier with the highest probability score for a given input data point wins, and its corresponding class label is assigned as the prediction. Think of it as a voting system, where each classifier casts a weighted vote based on its confidence. This is the final output of the model, the predicted species for a given iris sample, selected based on the highest probability score across the three binary classifiers. So, that's how the OneVsRest classifier approach works. This refers to the overall strategy used. The OneVsRest (OVR) approach means we train a separate binary classifier for each iris species, setosa, versicolor, and virginica. Each classifier tackles a simple problem. OVR is short for OneVsRest. Think of it as comparing one species against all the others. This is the famous dataset we're using. It contains measurements, like sepal length and width, petal length and width, for different iris flowers belonging to three species: setosa, versicolor, and virginica. These measurements are used as inputs to our model to predict the flower type. This is the first of our three binary classifiers. Its job is to learn how to distinguish iris setosa from the other two species, versicolor and virginica. It's a straightforward yes, no decision. Is this flower a setosa or not? This classifier focuses on versicolor. It learns to distinguish versicolor from setosa and virginica. Again, a simple is it versicolor or not classification task. The last classifier for virginica works similarly. It learns to classify whether a flower is virginica or belongs to either setosa or versicolor. This is the type of model we use to build each of the three binary classifiers. Logistic regression is a statistical method that predicts the probability of a data point belonging to a certain class. In our case, each classifier predicts the probability of a flower belonging to a specific iris type. After training, each classifier assigns a probability score to a new iris flower, indicating the likelihood it belongs to the classifier's target species. For example, classifier 1 might give a probability of 0.8 for setosa, 0.1 for versicolor, and 0.1 for virginica. The final prediction is simple. We choose the species with the highest probability score among the three classifiers. The classifier that's most confident gets to make the final call. Each binary classifier, one for each iris species versus the others, outputs a probability score. This score represents the likelihood of an iris flower belonging to that specific species based on its features. The famous iris dataset contains measurements, sepal length, sepal width, petal length, petal width, for three different species of irises: setosa, versicolor, and virginica. These measurements are used as input features to train and test the model. One of the three binary classifiers. This classifier learns to distinguish iris versicolor from iris setosa and iris virginica. The model learns what features differentiate versicolor from the other two species. One of the three binary classifiers trained by the OneVsRest classifier. It learns to differentiate iris setosa from iris versicolor and iris virginica. The goal is to identify features that uniquely characterize setosa. Another of the three binary classifiers. This classifier specifically learns to distinguish iris virginica from iris setosa and iris versicolor. The algorithm figures out what makes virginica different. After the three binary classifiers generate their probability scores for a given iris flower, the classifier with the highest probability score determines the final prediction. In other words, the species predicted is the one with the highest probability score. In this multi-class classification problem, the 1vs-rest OVR strategy is used. This means a separate binary classifier is trained for each iris species. Each classifier is trained to differentiate that species from the remaining two species.